So we have 6 possible phenotypes for a butterfly. So we've got an orange head, a yellow head, fuzzy wings or smooth wings, or bent wings or straight wings. So those are going to be our 6 possible phenotypes. So we're going to start with our parent function. So big G, big F, big B. It's going to cross with little g, little f, little b, little b. So here we've got our orange-headed, fuzzy, bent-winged butterfly, and it's going to cross with our yellow-headed, smooth, straight-winged butterfly. And they're going to produce an F1 generation that is 100% heterozygous. So now we've got we have, for our F1 generation, we're going to cross our purebred orange butterfly with smooth, straight wings, with our yellow-headed butterfly with bent, fuzzy wings. Our coefficient of confidence is going to be 0.8. So now we're going to draw a genetic map. So our genetic map has 15 centimorgans in R1 and 9 centimorgans in R2. So from our genetic map, we can write out our F2 generation. Now that we have all 8 of our F2 generation gametes, we can predict the probability of each event occurring. So these are all of our events, and now we're going to predict the probability of each event occurring. So I'm going to show you how to calculate the probability of our double crossover and our single crossover in one. So for our double crossover, we're going to take the percentage of R2 of R1 and the percentage of R2 and our coefficient, multiply all those together. So 0.15 times 0.09 times 0.8 gives us 0.0108 or 1.08%. For our single crossover in R1, we take our percentage of R1, so 0.15, and we're going to subtract it by our double crossover probability. So we're going to subtract it by this 0.0108, and we're going to get 13.92%. Now I have gone ahead and done the rest of the probabilities. So we've got for SCO2 7.92%, and for our no crossover 77.08%. Thank you for watching my video on reverse mapping. My reference is the textbook Genetics, a Conceptual Approach by Benjamin Pierce.